Hi there! In this video we're going to learn about simplifying a higher root. So what does that mean? It means we're going to use, I like to call the factor tree method, to simplify a higher root radical. So before we even go any farther, let's talk about higher root radical. So a radical is going to be something like this, and a radical is the check marky symbol that has two parts, actually three parts. So the actual check mark symbol, that's called the radical. The number that's in the corner is called the index. And underneath the radical, this part right here is called the radicand. Just some vocabulary. I'm not even really going to use any of that vocabulary besides radical. So just know that when I say radical, I'm talking about this check mark. Okay. So a higher root radical means in the index, normally the number that's there is nothing, it's not written, which means it's a 2. That would be something that you're used to seeing, like square root. Now I'm going to be dealing, with a higher root radical, which means I'm going to have a number written in that corner, and we're going to talk about how to simplify that with or without variables. To use the factor tree method, though, we need to know what our prime numbers are. So remember, a prime number is a number that's only multiplied by 1 in itself. So these are our list of prime numbers. We don't go very high. Usually, maybe the highest you'll see is up to 11. But these are our list of prime numbers, at least up to 23. Okay, so factor tree method says I'm going to take anything under my radical. So I'm taking my radicand, and I'm going to break it down into prime factors. So the best way for me to show you is to do an example. So what I'm going to do is I don't care about what number is here right now quite yet. First thing I want to do is break down my number underneath my radical. So you can choose any numbers that you want. It doesn't matter how you break down your radical. You will always end up with the same numbers as long as you do it correctly. So any two numbers that multiply to 54. Well, I know that 9 times 6 is equal to 54. Somebody might choose a different way, different numbers. The only thing you can't choose is 1 and 54. That's not going to be helpful in breaking down your radical. So anything else besides a factor of 1. So now what multiplies to 9? 3 times 3. Now anytime I get a prime number, I underline it. What multiplies to, 6? 2 times 3. Okay, so now here's where this number comes in my index. This number says I have to have 3 of a kind, 3 of the same number to take something out of my radical. So here I have 1, 2, 3 3s. Because I have 3 3s, I can remove a 3 from underneath my radical. And whatever doesn't have 3 of a kind goes back inside. So my final answer is 3 to the cube root of 2. Or cube root 2, not 2 though. 3 cube root of 2. Now you might say, well, why does this method work? Okay, I'm going to do it the other way that a lot of textbooks usually show, just to explain why this method works. So when you learned about square roots, you learned about something called perfect squares. A perfect square would be like 16. I can take the square root of 16 because 4 times 4 is equal to 16. So any number where you would multiply it 2 times, that number gives you the perfect square. So like, just as an example, so if I take my number and I square it, I get 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. These numbers are perfect squares. Now I can cube my numbers. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Okay? These numbers are perfect cubes. Okay? And you can go higher, but that requires me to remember what all those numbers are. And that, to me, I can remember my perfect squares, but to remember perfect cubes and then anything to the 4th power that's perfect or anything to the 5th power that's perfect gets a little tricky. It's a lot of things to remember. So, but here's what we know. If I broke down something, and let's just take this problem, okay, we have the cube root of 54. If I did this the way using the cube root method, okay, and the power and the rules of radicals, so I'm going to break this down. What's the highest perfect cube that goes into 54? Well, 27 is, because 2 times 27 is 54. So I would say this is the same as the cube root of 2 times 27. And I can break this apart. This would now be the cube root of 2 times the cube root of 27. But I happen to know the cube root of 27 is 3. So my final answer is 3 times the cube root of 2, which is the exact same thing that I got using this method with breaking down my square roots. When I use the factor tree method, I don't have to know what my perfect cubes are. Or what if it's higher? What if my index, look at down here, this one's to the 4th power. I don't need to worry about that. I just need to know that I can break down the number that's underneath. Okay? So, let's do the next problem. Break down 162. Okay, I like to start, it's an even number. I'm totally dividing by 2. 162 divided by 2 gives me 81. So this is 2 times 81. 2 is a prime number, but 81 is not. What multiplies to 81? 9 times 9. 9's not a prime number. What multiplies to 9? 3 times 3. This one is the same because it's also 9. Okay, now I look here. What number do I have here in my index? It's a 4. That means I have to have 4 of the same number in order to take it out of my radical. So here I have 1, 2, 3, 4 3s. So I can take a 3 outside of my radical, and then anything that doesn't have 4 3s goes back inside. So this is 3 times the 4th root of 2. This is my final answer. Let's try another one. Ooh, now we're up to 5th root. Okay. What multiplies to 128? Well, it's an even number, so I'm going to do 128 divided by 2 gives me 64. So 2 times 64. 2 is a prime number. 64 isn't. That's the same as 8 times 8. What multiplies to 8? 2 times 4. 2 is a prime number. What multiplies to 4? 2 times 2. And I'm going to do the same over here. 2 times 4 and 2 times 2. Okay, now I have to have 5 of a kind. Okay, 1, 2, 3, 4, 5. I have 5 2s, so I can take out a 2. And this is the 5th root. Okay, I have this 2 and this 2 both left over. So I have to move them both over here. I multiply them underneath my radical. Whatever I don't have, anything that goes back inside gets multiplied back together. So my final answer here is 2 times the 5th root of 4. Okay? Now let's add some variables. The concept remains the same. So what you're going to do is you're going to break down each base. So first I'm going to break down 81. 81 multiplies to 9 times 9, and 9 is the same as 3 times 3, and 9 is the same as 3 times 3. Then I have to break down my variable. X to the 4th is x times x times x times x. Okay, I need 3 of a kind. 1, 2, 3. I can take out a 3. 1, 2, 3. I can take out an x. What do I have left over? I have a 3 and an x. So those go back inside my radical. Final answer. Okay. Last one. Break down each base. So here I have constants, my number 96. I have x's. And I have y's. Okay, so let's break down 96. Give me 2 numbers that multiply to 96. 96 is an even number, so I'm starting with 2. 2 times 48 is 96. What multiplies to 48? 8 times 6. What multiplies to 8? 4 times 2. What multiplies to 4? 2 times 2. What multiplies to 6? 2 times 3. Okay, now I got to do my x's. I have 1, 2, 3, 4, 5 x's, and I have 8 y's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I need 4 of a kind to take out some base. Okay, so I have 1, 2, 3, 4 2's. So I can take out a 2. And I have 1, 2, 3, 4 x's. So I can take out an x. I have 1, 2, 3, 4 y's. I can take out a y. Do I have enough to take out another y? 1, 2, 3, 4. I have enough to take out another y. Okay, and what do I have left over? I have a 2, I have a 3, and I have an x. So what goes back inside my fourth root? I have a 2, I have a 3, and I have an x. So now I have to simplify this. On the outside, I have 2x y squared. And on the inside, 2 times 3 is 6x. This is my final answer. Let me know if you have any questions. Remember, just break down each base and you're counting the same number of things as it tells you in the index, which is the number like inside the check mark of the square root. Let me know if you have any questions. Good luck.